Good morning, folks. You find me in school today in the maths office. That's exciting, isn't it? I'm sparing you from my shiny head once again, as we've got very bright lighting in here, with a good old Norwich City hat. Yes, the greatest football team at the top of the hardest league in the world at the moment. But anyway, on to more important things. Talk about tricky stuff. I'm sure some of you are finding this vectors work difficult. Do not worry if that is the case. It takes a while to get good at this stuff. Some people do see it quite early. It's about two things. It's about sort of spatial recognition, and it's about ratio. Well, I'm going to have to put a third one in there as well, and it's a little bit of algebra. Mainly just expanding brackets and putting stuff into it, but it helps if you take a factor out as a fraction. So if this is all going over your head a bit at the moment, do not worry, that is normal. It's the first time you've tried to learn this stuff. I'm going to take you through 3 questions today. Have a little go at each one before I take it through, and if I've explained part of it, think, I think I could do a bit more, pause it then, see if you can. Every little bit you can do will help you get there, and at some moment, if you keep trying with it, that light bulb moment will happen, and hooray, eureka, or whatever it is you'd like to say. Right, okay, here goes with question 5. There's 5 marks for showing that C, M and D are on a straight line. Well, I can see M and D. Where's C? Right, now I would recommend using a bit of colour and stuff where you can. But C is the point such that OC to CA is 4 to 1. That means 4 plus 1 equals 5 equal parts that we've got to split this into. So I'm going to have a go at doing that. To do fifths, I normally go not quite as far as halfway, and halve that one, and then try and put this bit here into thirds, about like that. So O to C is 4 of those parts up there, and that just helps you to think things through. Now it says they're on a straight line, and it's not actually too far away from what I've done there to say, right, there's our straight line. Now, if it's on a straight line, we can say that the vectors for CM, CD, and MD, if we can find any 2 of those, need 2 of those, they will all be multiples, of a common vector. But you're going to pick up marks just by defining some vectors as you go, even though it doesn't say. So the important thing is to start having a bit of a go at it. And hope this bit makes sense. Mrs. Muggleton just walked into the office, so I'm not sure exactly what I was saying just then. But the important thing is to start defining things that we're going to need. So I'm thinking I need to get CM. In order to do that, we're going to need to do A to M, because A to M is easy. We can say first of all that AB is going to be plus 3b minus 5a, so that's 3b take 5a. A to M is going to be a half of going from A to B. So if we just do that, and that's going to be just halving them both, which we can just do without even working anything out by just using a fraction. I don't know where my B has gone there. Right, should be a B. Right. So that's A to M. Now C to M is going to be going from C to A, and then adding to that A to M, and we've just worked out what A to M is, tricky as it was. Now C to A is pips, because we've got 5 equal parts there, and C is 4/5 of the way up of 5A. So if that's true, CA must just be 1A, because that's 1A, that's 1A, that's 1A, that's 1A, that's 1A, all the way along there. So we can say that CM is going to be A plus 3 over 2B take 5 over 2A, and then we just need to simplify that. Now A is 2 halves, isn't it? So if I take 5 away, I'm going to have minus 3. So C to M is 3 over 2B take 3 over 2A. And probably find it useful now just to factorise that, but using the fraction as your factor. I know fractions aren't factors, but you can still do that. You can take 3 over 2 outside of the bracket and say, I want to multiply my B and my negative A by 3 over 2. So we have defined C to M. Now the other one, I think that doing C to D will be the easiest thing to do next, because C to D, let's bring in another colour at this point. C to D we can call C to A plus A to D. You may be thinking, well, what is A to D? Well, they've said that the ratio OB to OD is 3 to 4. So this is 3 for what that is 4. Well, if that's 4, then it must, and it's 3B to there, it must be 4B to there. So we can say that that is 4B, couldn't we? And therefore, we can say that C to D is going to be C to A, which we already know is A, plus A to D. Now A to D, just write it once up here, is going to be negative 5A and plus 4B, isn't it? 4B take 5A. So if I put that down here now, I've got 4B take 5A, which I can tidy up to call 4B take 4A, because 1 take 5 is negative 4. And I can then say I could factorise this and I've shown it, and I maybe just write a sentence or two just to make it really, really clear. Say CMD are on a straight line as C to M and CD are both multiples of B minus A, and they share a common point in C. So what that's saying is, if they're both multiples of P minus A, that proves that they are parallel. And if they've both got the same line in it, well, if you're parallel to something and you go through the same point, you must be on the same line. Okay, so parallelogram. Jot it down, pause the video, and do what you can. Right, so D is on the point OC such that OD to DC is 2 to 1. So I'm just going to put a little mark there, because to show myself that that is 2/3. So we can say, before anything else has happened, that OD is 2/3 of OC. And that might come in later, I'm not sure. E is the midpoint of BC, they've done that. And we need to show that AD and E are on a straight line. Now it's not enough, I'm afraid, just to get a ruler and do this, but it's not a bad idea because it makes you think about what's going on. So they're lying on a straight line, and we've got to we've got to do it algebraically. We can't just do it with a ruler, so I didn't get any marks for doing that. But I need to start defining some of these things. So it's similar to the one before in that we're thinking about AD and we're thinking about AE, and if there's a multiple, so there should be some number, I'm calling it K, that you would multiply AE by to take it down to AD, or the other way round. So let's start off by trying to work out how am I going to get from A to D. Well, I should say that AD is going to be A to O plus O to D. And I know that O to D is 2/3 of O to C. So what is O to C? Let's put that down here. O to C is going along there, which is 2B. And then if I go up there, parallel to what's there, that's 2A, isn't it? So 2B plus 2A, or 2A plus 2B, is OC. And we want OD, which is 2/3 of that. So if I come over here, I can say that my AD is going to be, I've got to do A to O, which is easy. It's just the negative of that one. So that's minus 2A. And then I'm going to want 2/3 of this. So I'm just going to write that using a bracket first of all. 2/3 of 2A plus 2B. And then the thing to do is expand and simplify. So A to D is going to be minus 2A plus 2 times 2/3 is 4/3 of A and 4/3 of B. Then we can simplify that. A to D is going to be, well, 2, if I take 2A away, that's 6/3, isn't it? So that's going to give me 4/3 of B take 2/3 of A. And at this point, we could say, I could sort of have a go at factorising that a bit, couldn't I? 1/3 4B take 2A. I could take 1/3 out, couldn't I? And that's AD. So we've done AD. Take another colour to make things a little bit less confusing. And let's do AE. Now AE is going to be really quite easy, I think, because if I go over here for AE is that, which is minus 2A, isn't it? It's that, which is 2B, and then it's half of B to E, which is plus A. So AE is going to be negative 2A plus 2B plus A, and that simplifies down to 2B take 1A. So I've got 2B take A there, and what's the similarity here? I need 2B take A here. I could take a factor of 2 out of there, couldn't I? And that would give me AD is equal to 2/3 of 2B take A. And at that point, we've shown it because both AE and AD are multiples of 2b minus a, we have shown it. Right, final question then. Pause the video, have a go at getting as far as you can. It's similar, not exactly the same. So first thing that I would do is look at where the point P is going to be on here. O to C to A is 4 to 1. So that's 4 parts and 1 part making 5. So I split it into fifths, about like that. So my C is going to come about there. It says that C, D and E are on the same straight line. Strictly speaking, they didn't need to say straight. A line is straight according to maths. If it's not straight, it's a curve. So that's that bit of information in there. A to D to B is 1 to 3, so 1 to 2. So 1 to 2 means we're splitting into thirds because we've got 1 plus 2 makes 3 parts. And so little things that I'm thinking that could get you a mark straight away is if I was going to try to do A to D, I'm thinking I know that that's going to be the same thing as 1/3 of all the way from A to B. So whilst I'm thinking about that, what is A to B? Well, it's going the other way of the 5A. So I'm going down here and then plus the 2B. So AB is going to be 2B take 5A. So that means that A to D is going to be 1/3 of that, which looks a bit confusing. And so we must always be ready to expand our brackets as well. So timesing by 1/3 means 2/3, and 5 times 1/3 is 5/3. So you don't have to work out what 5/3 is, you just write it as a fraction. Makes everything simpler. So that's AD. And I also I'm going to need to consider, so that's A to D. I need to consider CD, don't I? So CD, hopefully this is starting to get a little bit familiar now, is going to be made up of me going to A and then going from A to D. And that will give me the same thing all in all. So CA, because this is into fifths, each one of these must be 1A. So C to A is A to D is 2/3 B take 5/3 A. So our C to A, well, A is 3/3, so 3 take 5 is minus 2. So that gives me 2/3 B take 2/3 A. And when you've got that fraction there, remember that it may be useful later on to take a factor of 2/3 out of both of them. 2/3 times B times 2/3 times negative A. Right, so that's thinking about CD. So now we're going to need to think about CE. And CE will also be a multiple of B minus A. But how do we get there? Well, first of all, let's think, well, we know what it is. In fact, it's not that nasty. Let's go with a new colour so that so CE is going to be C to O, because that's easy, isn't it? That's minus 4A, because we're just not having to bother with the A at the top, plus O to E. In fact, we could break that down further. We could say plus O to B plus B to E. And the only thing we don't know is E. So let's fill in what we do know. We know C to O is minus 4A. We know that OB is 2B. And then we need to add whatever B to E is. But we know that B to E is part of this straight line. So it's got to be a multiple of B. So plus, maybe call it NB, although they often like using K in vectors, but never mind, I've done an N now. So what we've got here is 2B plus NB take 4A. But what I know from this is that anything on this straight line here is going to be a multiple of B minus A. So CE equals a multiple of B minus A. Now we know how many A's we've got exactly. So we know that we can take that factor of 4 out. So I could say that this is going to be 4 and then B minus A, because that's the only way I can get 4A, because all the A's are dealt with. Now that means that 2B plus NB makes 4B, doesn't it? Well, if we've got 2B, then this bit here must also be 2B. And that is the question to find, or the answer to the question that we wanted, which was BE. So BE is 2B. And that's all it is, folks. Alright, I say that's all it is. I know it's a little bit confuddling. Anyway, I hope that's made things a little easier for you. And we will be moving on to a new topic next time.